In part 3 of this module, we're going to talk about ozone depletion and ozone gases and quickly about international strategies of both ozone and global warming. So, as we know, the atmosphere is a protective layer. It keeps us warm, but also there are another important group of chemicals that we've looked at already in environments through time when we've talked about ozone production. Okay, these chemicals are very important in protecting life on Earth, but recently they have been eaten away at and destroying a part of the atmosphere. So the ozone layer acts as a protective barrier against UV radiation. It blocks out approximately 95 to 99% of these harmful rays from the sun. It consists of 3 atoms of oxygen and it collects in the stratosphere. It's constantly being made because of interactions with incoming ultraviolet radiation. Photolysis, if you remember. Certain chemicals easily break down this molecule. The main offenders are CFCs, which we earlier discussed as greenhouse gases, the chlorofluorocarbons. So a CFC molecule with UV causes a chlorine atom to break away from the CFC molecule. The free chlorine atom hits that ozone molecule. The chlorine atom pulls one oxygen away from the ozone. Then a free oxygen atom hits the chlorine monoxide molecule. The result is another free chlorine atom, and the free chlorine will continue to deplete ozone in the stratosphere. CFCs are very stable and can remain in the atmosphere for up to 75 years. When they finally break down, they are very active. When CFCs break up, they form chlorine radicals, which is Cl negative. These chlorine radicals are then able to react with ozone and convert it back to normal oxygen. This results in less ozone to protect us. So a lot of, unfortunately, just like pesticides which stay in the atmosphere and in the environment, they bioaccumulate. They're very hard to break down. They're very hard to get rid of, and this is part of the problem. CFCs originate in cities all over the world. However, they are transported to the poles because of the Earth's rotation and wind patterns. The ozone depletion reaction also occurs at a higher rate in colder temperatures. As a result, there is a hole in the ozone layer above Antarctica. Satellite imagery has enabled scientists to monitor this hole. Evidence from images, along with surface monitoring of UV radiation, suggests that the ozone is depleting. This evidence has forced governments to do something. In 1987, a treaty known as the Montreal Protocol was signed with the aim of saving the ozone layer. The Montreal Protocol called for a cutback in the production of ozone-depleting chemicals by 50% by the year 2000. The treaty has been revised twice and now states that CFCs would not be produced after 1995 and that other halocarbons would be controlled until 2030. It's hoped that this will lead to the recovery of the ozone layer by 2050. However, because CFCs do not break down quickly, it may take much longer to notice any changes. As discussed earlier, the Kyoto Protocol commits 38 countries to cutting greenhouse gases back to 5.2% below the 1990 levels by 2012. The Montreal Protocol reduced the production of CFCs, however, replaced their use with HFCs, which are a greenhouse gas. So there are still issues that need to be sorted out. Australia has played a critical role in monitoring and research in regards to ozone depletion. And the reason is because we are highly affected by this hole in the ozone layer. Basically, CFCs were used very highly and they were very important. But now we've realized that it's depleting. And therefore, a lot of the time, Australian scientists have been involved in the ongoing research. And they two scientists that is important to look at. It includes Paul Fraser and Jonathan Banks, and I've got that information for you to read in your worksheet. Severe depletion of the ozone layer over the Antarctic has been occurring since 1979. And the levels have declined by about 3% between the late 1970s and the early 1990s, 3 times faster than recorded in the 1970s. The Antarctic hole is mapped by Total Ozone Mapping Spectrophotometer, TOMS, carried on satellites and aircraft. Australian scientists are among the most efficient in the world when it comes to finding causes for ozone depletion, as well as finding alternatives to chemicals found to reduce the amount of ozone in the atmosphere. In Cape Grim in Tasmania, a team of scientists working for CSIRO collect some of the most pristine air samples in the world. From these samples, the scientists can determine which pollutants are present in the atmosphere. The team discovered that the ozone-depleting gas, halon-1202, although it only has an ozone depletion potential of about half that of common CFCs, it's in fact increasing in abundance of about 17% per year. Halon-1202 could be a byproduct from the production of other known halons, or it may be being made deliberately for military applications. Okay, alright guys, good luck with completing this module. It is a very big one. There's a lot to read about and a lot to understand because there are so many different industrial chemicals that are affecting our environment, causing the depletion of the ozone layer, and you can have a look at the different types provided, complete the activities, and make sure that you try the little quiz as well. If you do the quiz, you'll be able to see whether you have an understanding